This Hughes Autoformer could have saved us a ton of trouble when we were in Las Vegas recently and the temperature was 120 degrees and we only had 103 volts. But does it steal power from your RV neighbors? We're going to get into that and do some testing. Let's go. We first heard about this Hughes Autoformer way back when we started out RVing, and a little bit of research at that time came across some stories and some articles about how it steals power from the neighbors and it might be banned in RV parks, and we just kind of didn't look into it much more after that. After our horrible time in Las Vegas with 103 volts, I started to do a little more research on this, and as I researched it more and more, it became really clear that people are passionate on both sides of the argument about the stealing power issue. My personal take is it depends on the type of load, but we'll get into that later. For the record, this is not a sponsored video and we did purchase our own Hughes Autoformer. Before we jump into that controversy and do some numbers and some testing, we do need a little bit of a refresher on watts, amps, and volts. Don't leave, don't worry. I'm going to keep it really high level so that it's easy to understand even if you're not familiar with any of those terms. I like to use a water analogy like a lot of people do for things like volts and amps and watts. Think of volts like water pressure. So you've got a water hose and it's got a super high amount of pressure, high voltage, or low pressure, low voltage. And then the flow of that water is your amps. So it's a combination of that pressure and flow that gets work done. And that work is measured in watts. All of that is just to give you a feel of why it's a combination of both things. Mathematically, volts times amps equals watts. And knowing that volts times amps equals watts, we can manipulate that around with some simple math and know that volts is also equal to watts divided by amps, or the amps is equal watts divided by volts. This is going to become important, but it's real simple math. Now that you understand that relationship, I have some whiteboard drawings and we're going to kind of see how this thing works in theory, then we're going to go do some tests. Before we jump into some examples, I want to address the whole stealing power controversy. I'm going to go a little bit deeper here, but give me 30 seconds and I promise we'll come back to high level stuff. There are good arguments on both sides of the stealing power debate, and it really depends on what type of load you have. So in an RV, you're going to have both inductive and resistive loads, and don't worry about that, I'm going to kind of explain. An inductive load is something with a coil and a wire like an electric motor. These are going to be things like your fan motor on your AC, your compressor, basically anything with a motor. And those are typically going to be your higher draw items too. They're going to draw more power. Now those types of loads, when the voltage goes down, the amperage automatically goes up to compensate. And that's why those types of loads are more prone to problems with low voltage because they're drawing a lot more amps. They can actually damage them. But they will automatically draw more power when the voltage drops. Now, a resistive load is something like your water heater's heating element, things with resistance like that, light bulbs, probably like a hair dryer, things like that. When the voltage drops, their power drops. So the thing to remember there is, if your power drops on your water heater, it's going to run longer. So it's still going to take more amperage, but over time versus at a particular instance. So my contention is that your RV is going to be a mixture of inductive and resistive loads, but most of your bigger loads are going to be inductive, meaning they're going to draw that amperage whether you have an autoformer in the line or not. That said, my upcoming drawings and things and examples that I'm going to show you are theoretical, and they're really kind of looking at the whole thing as one giant inductive load, but in reality in your RV you're going to have a mix of both, and they're both going to draw more amperage with low voltage, just in different ways. One is going to be in instance and the other one is going to be over time because it takes more time to do the work with less power. So let's get into it. So first, let's look at two quick easy scenarios and then we'll introduce the Autoformer and see what changes. Our fixed device here that we're going to talk about for our first scenario is just a real simple 1500 watt load like an AC unit or a microwave or something along those lines. With good power, meaning 120 volts at our pedestal, you can see that this 1500 watt load actually draws 12.5 amps. Again, that's really simply 1500 divided by 120 gives us 12.5. Now running that same 1500 watt load with say 105 volts, different story. Because it's a yin and yang, it's a little bit of both. The amperage now has to climb up to 14.3 amps versus the 12.5 to run the same load. Now let's step it up, make it a little bit more real. Let's power on all 3 ACs, let's run a bunch of stuff, whatever, it doesn't really matter. But let's use 6,000 watts as an example. This is actually half of the capacity of your 50 amp RV. You've actually got 6,000 watts available on both sides, but we're not going to go into that. We're going to keep it simple. So you can see that with a good power supply, 120 volts, we're going to draw 50 amps of power to produce this 6,000 watts. However, if we have bad power, say 105 volts, which is actually better than we were getting in Las Vegas, you can see we're going to draw over 57 amps. So the more you use, obviously, the difference is quite a bit bigger. So why do we care? Why do we care whether our system is powered with whatever mix of amps and voltage? Well, because low voltage means high amps, and high amps are actually bad for a lot of your gear, particularly things like your AC compressor and things that have inductive motors. It's just things have to work harder with a higher amperage to actually do the same amount of work with low voltage. Additionally, the more those amps climb and get towards those thresholds for your breakers, either inside or outside, you're going to start tripping breakers prematurely with low voltage. And the big trouble there is if you went to the RV park and said, I'm blowing my breakers inside my RV because your voltage is low, they're not going to get it. Usually they're just going to say, your breaker blew, it's your problem. But now let's see what happens when we throw the Autoformer into this same situation. But before we do that, I'd like to point out one thing on this drawing. You'll notice that the higher amperage draw, the 57 amps versus the 50 amps, that is being drawn inside the RV by your devices like your AC units and microwave and things like that. And it's being drawn through the entire RV all the way to the pedestal. The extra amperage is already there being used because it has to. So now let's put the Autoformer in the picture. We still have 105 volts from our pedestal. Nothing has changed there, but because of its 10% boost, we have 115.5 volts on the RV side of the Autoformer. And this is where it gets really cool. We have the same load of 6,000 watts. We're still going to draw 57 amps from the pedestal, but because we've bumped up the voltage at the Autoformer before it goes into the RV, and we have 115 volts of power there, we're only going to draw 52 amps versus 57 inside the RV. So you can see what this thing really does, because that 57 amps is going to be drawn from the pedestal regardless, is it just isolates the RV. And by bumping up the voltage, it decreases the amperage that your RV has to draw. This protects your RV from those higher amps and just isolates it to the circuit between the Autoformer and the pedestal. Nothing really changes. It's not going to draw more power. It's just shifting the point where that power is drawn. Additionally, I'd like to say that even if it did draw a little bit more juice to create the voltage and protect your RV, it's never going to draw more than that circuit can handle, which is why it has breakers on the pedestal. You're never going to draw more than 50 amps through that because the breaker will blow. So a real world check here. How could this have helped us in Vegas? Well, even after we got moved to a site that had better voltage, and I think it was maybe would vary between around 110, 115, somewhere around those lines, this could have helped us out tremendously. Because even though we were getting okay voltage, a boost would have done wonders for us. We had to actually put a fan down by our breaker box and blow it on the breakers because the amount of current we were drawing for our AC unit was right up on the edge of the breaker. That combined with the fact that it was 120 degrees outside, 105 at night, it was tough to keep it cool in here. And these breakers operate off of current and heat. And when the ambient temperature is higher, it kind of affects their breaking point. So this would have helped tremendously in Las Vegas. I wish we would have had it, but now we do. Does it actually work? Let's go see. This Autoformer operates in two modes. One is just straight pass-through mode. It does actually boost 2% when it does that. It'll use pass-through mode when you've got 114 volts or higher. However, when you have 113 volts or lower, it goes into boost mode, which boosts by 10%. Now, this ugly little thing here is a variable transformer. This is what's going to allow me to dial down the voltage and test this thing out. Unfortunately, this is only good for about 1700 watts, so we can't really do a full-blown, nice, heavy load test like I mentioned, but we can do a voltage test, which is what we're going to do. Now you'll notice, as soon as I turn on power, the Hughes Autoformer will come on and give us an indication of the power situation and tell us if there's anything miswired or something like that. Pretty quick to tell us we have all green lights. Of course, if you have anything that's not right, you can read the indications right here and see what's wrong. You can also see right now it's not boosting. At this particular moment, our surge guard has not kicked in, so it's not actually connected to anything. And I'm going to test the voltage before it kicks in because this thing is a piece of garbage and won't let me dial it up to an actual 120 volts. You can see that we have 120.6 volts. And on the output of the Autoformer, we have 123.3. So that is the just 2% boost that's in bypass mode. You can tell it's in bypass mode because both of these lights are off right now. We will give it about 90 seconds and our surge guard should kick in, put a load on the system, and that'll cause this piece of junk to drop its voltage because it's garbage.
That piece of garbage.
This is going back.
Yeah.
But it does at least allow me to bring the voltage down to test this. Okay, so we have the load on now. We're actually running the RV through this system. And you can see I'm already at 109 volts right here. And it's already boosting. I'm going to crank this down till we get a little bit lower. You can see how cranking it down, it goes up first and then down. It's a piece of garbage. We can see, okay, we've got what, 105.34-ish there on the input. Let's check the output. It should be boosted. Boom, there you go. So perfect. It boosts just like it says it's going to. Let's go back inside. So as you can see, it does the job just like it says it does. You know, I wish we could have tested at a much higher wattage and done amperage testing and all that, but it just wasn't possible. A couple of notes also about this. It does provide surge protection, so that is really cool. Additionally, the surge modules in here are replaceable. It has to be done by Hughes, but if the thing burns out from a surge, you can send it in, get it serviced, have those modules replaced. You can also use this 50 amp model with 30 amp or 20 or 15 amp with dog bones like we've done before. Not a problem. This model is designed to go outside, so it's got a little handle on it. You can just set it down out there, plug it in, and you're up and running. It does also come with a lock, so you can lock it to the pedestal, and you can buy a rain cover for it as well. Now, if you don't want to deal with that and you want to have it all just inside, which is like how we usually like to do things, this does have an optional kit for hard wiring, and you can just put this inside your RV between your shore power connector and whatever else is downstream, probably an ATS or your distribution panel. We will probably wire this in hardwired at some point. If we do, of course, we'll have a video or a short or something on that.